Hello, folks. That's not for your class. Don't worry. That's for my analytics class. Hello. I know. We can't wait. We got to start right. It's just 1 minute. 1 minute behind. I know you're impatient. I am too. Welcome. Let me put my ears on. It's more like a general thing. Like classes in general are in session. I'm supposed to put something. I didn't know what to put, so I put classes are in session. I'm open to suggestions. Okay, let me get my dashboard thing pulled up. Cool. All right. 6 viewers. That's not encouraging. Hopefully it's going to go up. Because otherwise, people going to miss out. People going to not learn today. Right? People going to learn today. Except that you're not going to learn. No, Jessica. No, you're good. You don't need to be here. I'm not sure what you mean. Let's take a look at the Discord together. Section 4. Shows me on my screen it has you as offline. Bye, Jessica. Excuse me. Is it possible that you are not signed in on the right account? Hello, Dorothy. Hello, welcome. Okay, got some more folks trickling in. It still says 6 viewers. I'm getting more people in Discord though. Oh, don't do that. No. I want this button. Okay, this says 16. Okay, I don't know what's going on. I feel like this viewer count's really laggy on the mobile dashboard anyway. Okay, well, we're getting there. All right, might as well start. Okay, so welcome back, folks. Hello. Howdy, how are ya? How the heck are ya, as my mom likes to say. Truth be told, I'm not taking attendance based on who logs in because of how like usernames and stuff are. It's a little tricky to do attendance. I thought about doing something like a Google Doc where you have to like log in at the right time and mark yourself as present or something, but it just didn't seem like it was practical. So for the time being, I'm using your participation in the Mind Tap assignments and vocab quizzes and things like that as confirmation of your participation. That's what I'm doing. Okay, folks. So just a little something for you. So I've put up Exam 2 Jeopardy. Just if you want to tinker with those, there is a Jeopardy thing like we did for the first chapter, our first exam. Unfortunately, we will not have time to go over it and play with it. I wish we would, but we won't. But it's here. There's some questions. However, most of the ones over here. Hey, Fred. Most of the ones over here in the 5th column, which is continuous probability distributions. Some of that won't be relevant, but you can ignore it. Okay, so announcements. Let's do the announcements thing. That's always good. All right. Open the PowerPoint. Here I go once again with the email. Hey, Strong Bad, can you draw a dragon? Sure, I can draw a dragon. Feel free to follow along with my simple step-by-step instructions. I make drawing fun. Ah, strong bad. And the Trogdor video. If you don't know that video, that's an oldie but a goodie. All right, so review stuff, climate study survey, and MindTap homework. Those are pretty well the same as before. Wait, I didn't want to close it. No, come back. Come back, Ali. Come back, Ali Seaster. Can't hear me. I think everybody can hear me. So that might be on your end. Are you muted? It's happened before. Put that over here. Okay. Mo can hear me. What do I have? Was it this one I was using? Yeah, that works. Okay. Mo can hear me, so Michael, see if you can't figure out. See, John says loud and clear. Okay, so might be on your end. Let me know if you can't get it figured out, Michael. Worst case scenario, if you never get it figured out, I can. Yeah, worst case scenario is you can watch the VOD, unfortunately. My internet was crap this morning, so it's just kind of how it is, unfortunately. And the things I'm going to say are on the screen, so. Okay, so here's the big thing. So I spent hours yesterday arguing with myself about how I wanted to do the exam because I had a pretty good idea of what I was going to do, and then I realized that I couldn't do what I wanted. And so I came up with another plan, and I can't do that either for technology reasons. Like the technology I don't have access to the technology to do what I want. And so my big issue, by the way, so just to make sure I'm clear. So the big issue is I really want to, as much as I can, I want students to be able to get credit for partial credit. I really don't like the idea of just taking an exam I would have normally given you on paper, which I would have graded partial credit, and then just kind of saying too bad, all or nothing. That's not good. I don't like that. So I've been playing with it, tinkering with it, trying to figure out what I can do, because it's no use dwelling on what I can't do. I need to know what I can do. So I've wrestled with it for a while. And so what I finally arrived on is what I will discuss right now. So there are two major changes to what I said on Monday. So number one, the exam is going to be broken into a few different pieces. And when I say broken into pieces, I mean like where I would have had like problem 1 with a prompt and then questions under it, that'll be an entirely separate assignment. As far as D2L's gradebook, D2L's quiz tools are concerned, it'll be entirely separate. So there will be, maybe not like every problem will have its own quiz, but it might. I need to see what I end up with as I start tinkering with this when I actually build the thing. I don't know how it's going to look exactly, but in concept, that will be the idea. So basically, I'll take a relevant clump of questions, group it into one quiz, and then you will be given a time limit for that specific chunk of questions. However, here's the interesting thing. So you'll have access to that chunk of questions. And then the chunk of questions, there'll be short answers. So you have to type in the number. It's not multiple choice. But you type in the number, and if you get it right, obviously you get points. If you get it wrong, you can retake the questions with as many times as you want within a certain time limit. Now, there are going to be a couple conceptual questions, I think, and those will be one try only because it's multiple choice. I don't want you to just guess 4 times and then, oh, it's that one. That's obviously not really useful as an examination tool. But largely, most things are short answer. I think there's only, my practice exam is like 2 questions like that. So very small number. Whereas, so the short answer ones, as much as I can, I am going to make several different versions. So that, I think when I did this, I did something like this last semester, and I made 8 versions or 10 versions of the exams. So it will be, you will not get the same exam each time, basically. You'll get a similar exam. So you get it wrong, it'll be the same problem, just with slightly different numbers. So you won't be able to just guess and check a whole bunch of times until you just luck into the right answer. You're like, oh, maybe it's this, maybe it's that, maybe it's this thing. I don't know. It will be hard for you to just guess and check like that. But if you have a good idea of what you're doing, and you're saying like, ooh, I think it's either this or that, then you try the this method the first time through. And if you don't get it right, you do it again with the that method. And then hopefully the that method was the right one, and you get full points. So I'm not going to average your scores or anything like that. I'll just take the highest score you get. Now that's going to be the highest score across the entire group of questions. So if there's 4 questions and you get 3 right and 1 wrong each time, you take it twice and you get like right, wrong, right, and you do it again and you get right, wrong. Both of those are a 3 out of 4, and you'll get a 3 out of 4. I'm not going to like super score the attempts. So each, like I said, so all of this, there's going to be several, probably like 4 or so. I'm not sure yet, but about 4 different sections, and you will have a separate time limit for each of those sections, but you can attempt it as many times as you want. Obviously, I won't tell you the right answer. I'll just tell you if your answer is wrong or correct. So I'll say the computer will say correct or incorrect. On the practice exam, it'll tell you the right answer, but on the actual exam, it will not tell you the right answer. You will, of course, just know that yours is wrong, but you'll have the opportunity to redo it. So the trick is, the challenge to this, the big asterisk, the big except, the big but, is that D2L does not have this functionality built in. So like I said, many of the things I wanted to do are just technologically infeasible in an easy way. So this one I'm going to have to do the hard way. So what I'm going to do is everyone will tell me when they want to take each of the sections of the exam. My headset just turned off. Come back. Everyone will tell me when they want to take each section. So what I'm going to do is, once I have the exam made, then I will create a quiz where it'll be like, when do you want to take section 1? So it'll say like, there are 4 sections, and you'll have 20 minutes to take section 1, you'll have 40 minutes to take section 2, you'll have 30 minutes to take section 3, and 30 minutes to take section 4, just for example. It may not be those numbers. I'm making them up as we go. So let's just say those are the numbers, and then I'll give you that list, and then you'll get to decide where or when you want to take each of the 4 pieces. So you will have like a little drop-down thing. I'll set a little drop-down, and you'll be like, I want to take section 1, which, by the way, you won't know what section 1 is. It's just a section, the first one, the section I'm calling number 1. It's arbitrary. So you'll just say, I'll take the 20-minute one at this time. And so you'll have 30-minute increments to choose from. And then just to make it easy to type in the data. And then I'll have to go through and manually add every person. I'll have to give every single person their own like manual access to the exam, to every portion of the exam. So, I have like 70 students, and there are, we'll say, 4 sections. So I'll have to put in like almost 300 manual exemptions. It's going to be awful. It's going to take me hours. But that's what it is. So I don't really have a good way around it. I have looked at a whole lot of options for what we might do, and I think this is the best one. Nothing's perfect. It's just kind of the way it is. It's the best I can come up with. So my plan is to have this quiz available Friday. So this Friday, of course, the 10th. My goal is to have this quiz available starting Thursday at midnight. So tomorrow at midnight, I'll have the exam finished. And I'll make this quiz so you can start signing up for sections, and you'll have 24 hours to sign up for the sections. And then I'll probably make it so you can start taking the exam at like 8 a.m. on Saturday to give myself a few hours to get a few people's exemptions put in, a few people's access put in. Obviously, if you say at 11:50, I want to take an exam at midnight, I won't be able to get that put in time. I won't know it's coming. So I'll have to give myself a little bit of time to put those in. So you will need to go and fill out that quiz sometime on Friday. So it's very important that you do that. If you don't, then you won't have access to the exam until you ask for it. The quiz. So it's under the quizzes. Again, there are assignments and there are quizzes. And so it'll be under the quizzes thing when they'll say like exam 2 sign up or something like that. And then you tell me. Now, look. You tell me when you want to start each section, drop down list in 30-minute increments right here. About what, Jessica? Yes. So what's highlighted? What's highlighted? What does this say? Okay, then sign up for consecutive windows. I mean, you can't literally do all the questions at the same instant, right? You have to do them one at a time. So if you want, you can sign up for 10, 10:30, 11, 11:30, or whatever, if they're half an hour intervals or whatever that is. Then you can do it that way. You're welcome to do whatever you want. So no, you will have 4:11 to 4:13. It's going to be Saturday to Monday. So Mo, yeah, you've got to do homework for chapter 6, but it's just one thing. You have to learn one new thing for chapter 6. And most of the exam we've already covered, so it's not new. And the homework for chapter 6 is like 4 questions. It's not long. It's pretty short. So that gives you 2 days. So Saturday and Monday you can work on the exam. Yeah, I know. A lot of people are still working. I understand that. And I know it's fast. Losing another week really sucks. And then trying to do all this technology stuff really sucks. It just takes a lot of time trying to figure all of this out. It just sucks. It sucks for everybody. There's only so much I can do about it. So this is what we got to do. We got to do the one section from chapter 6, which we'll talk about today, it's not too complex. No, it's. So the good news is the total time that the exam should take is like 2 hours or less. That's what I'm expecting. I have two. We'll say 2.5 hours or less. At like absolute most, be 2.5 hours. So 2.5 hours or less for the total thing, and you can break it up. So like if for Fred, like if you're working for 4 days, then you're gonna have to, maybe you want to do like you do the homework on Thursday, you do like work on the practice exam on Friday, and then maybe you break up and you do like a section each or something on Saturday, Sunday, Monday, something like that. So you can break it up and do little pieces at a time. You can do them in any order. You can do them in groups, not in groups. It doesn't matter. Is the practice exam going to be similar? I mean, yeah. Why would I give you a practice exam that's not similar? So yes, of course. In terms of format, yes and no. So I really went back and forth about how to structure the practice exam in terms of helping you understand the format. And I polled the earlier section, and they were with one vote off of unanimous for leaving the practice exam in a single document and making it one big quiz. Again, what I mean by that is one big thing under the quizzes heading, so that they can just see it all at once and not have to mess with going back and forth through different quizzes and stuff like that. Let me keep going on some of these questions because I still have more things that are on here. And you guys are, as usual, you're asking questions before I get a chance to answer them. In the slides here. So we're still on we're still right here in the thing. There's still a lot more to talk about. Okay. Erase this. Okay. Pointer. Highlighter. Okay. So number one big change. First big change. Headset, please. Change number one is exam broken into pieces. Change number two, big letters right here. It's not doing anything. Please. There we go. The exam is open book, open notes. So, here's the trade-off. There's no way for me to do partial credit directly. I tried, I considered it. There used to be something in D2L called long answer questions where you can literally type in math and like show work and build equations and stuff. And that's just a nightmare. Like you don't want to have to type that in. I don't want to try to decipher it. And that's just going to it's going to triple the length of the exam. It's just going to be a total nightmare. We don't want to do that. And the only other alternative is to break the questions into such meaningless pieces that it either becomes a real nightmare to like actually take the exam because it's like, what's the first step? What's the second step? What's the third step? What's the fourth step? Just ad nauseum. And it really starts to diminish the significance of the exam that I have to spoon feed you every single step, which is I want you to be better at the problems than that. And it's just not feasible. So to make up for it, the exam's going to be open book, open notes. So this gets me to Sujan's question, which is my point that I'm getting questions asked ahead of when I would have gotten to them beforehand. So let me just keep going. So, because it's open book and open notes, I recognize that you will need access to MindTap ebook. So that means you can't use the lockdown browser. So if you're having trouble with lockdown, not to worry. You don't have to worry about it. You can just use the regular browser. So it's open book, open notes. So, use your book, use your notes, whatever. You can have all that stuff. But the flip side is that there's not going to be any partial credit given. So, like I said, when you take each section, You'll be graded at the end of the section. It'll tell you your score, so you'll know which questions you got right, which questions you got wrong, and you can decide if you want to retake it. So generally the rule of thumb is that whatever time it would take me to solve a problem, I give students 3 to 5 times as much time. So like if I can do a problem in 5 minutes, I would give you somewhere between 15 to 25 minutes to take that. And the number that I have in my head is that I'm going to double that. So what that generally means is like I'm assuming that you're going to have like hesitation, debating on this formula, that formula. Maybe you have this question or that question, and you got to work your way through it and make sure you come up with something that you're happy with. So I'm assuming that you're kind of trying and testing things already in that 3 to 5 times multiple, and I'm going to give you the opportunity to do that a second time. So I'll roughly double the time that you have that I would have given you otherwise. So that doesn't mean you get 2 attempts at the problem. It means you should get like 3 or 4, especially considering hopefully part of it you'll be pretty comfortable with, and so you'll do part of it quickly, and they'll give you a lot of time for the other parts. So that is the best compromise I can come up with. I've argued about this. I've talked about it with some other people and tried to find the best solution. And this is the best thing I can come up with. So exams in pieces. You take the pieces separately or together if you want to. Like Jessica was saying, you can take them all at once. It's totally fine. I don't care. I want you to have the option to take them separately, to get some food, take a break, take your kids outside, something. So this is a recap. What's on it? Chapter 4, Chapter 5, but not hypergeometric, and normal distributions. Today we're going to be finishing up. I wanted to review. We're not going to get to. And there's a practice exam that's available. Remember, it's under quizzes, like everything else is for these kinds of things. It's under quizzes. So look for it under quizzes, even though it's not a quiz, it's an exam. You'll find it under quizzes. Look, Mo, I understand that it's difficult, but here's the alternative. I give you a 75-minute exam. It's multiple choice or short answer, and you get 1 try, no partial credit. I mean, I can do that if that's what you want. You want an all-nothing 1 shot is all you get? That's easy for me. That's easy for me to do. You don't want that. You don't want that. And a lot of people have been unhappy. A lot of people are unhappy with me, like, consistently. And a student in my class yesterday was like, man, why are you doing this? Why are you introducing all this technology stuff? And I was like, what do you want me to do? Like, honestly, what do you want me to do? Analytics is a computer class. Like, we got to do computer stuff. And we got to do math. That's this class. You got to do math. And I don't know how to make it fair other than this. So, it is what it is. So, here's my other compromise. Emotional support, Kitty. Oh, yeah, you were there for that. That was funny. Yep, Mo came and visited my other class yesterday, or one of my other classes yesterday. She popped in. Jessica, who was here a little while ago, a few minutes ago. No, Arthur, come back. Come back, Kitty. Jessica, who was here a few minutes ago, is in the class that Mo popped in for. We were not playing a game. That's not true. We did a vocab quiz. And some students finished early. So they came back to the chat and they were asking me questions. So we were talking. Arthur Cat, Arthur Cat. Okay. Now I've covered everything about the exam that I want to cover. So if you still have questions, this is a good time. Where's the dog? My family's eating dinner right now, so they are absolutely up there trying to scrounge scraps off the table. We're going to go over the 1 section. That's what we're about to do right now. And that's it. It's the one thing. Whew, kitty, where's your brush? Oh, right in front of me. Awesome. Just the one section. We're about to go over it right now. Can you see this hair? Probably not. Oh, yeah, you can a little bit. This, like, white streak. This cat is shedding. It was over 80 degrees today here. All right, your buddy. It's real bad. Okay, any other questions before we move on? No. All right, bye, cat. Ugh, Mo, I wish it were only the cat. It is the cat, but it's also the dogs and pollen because it is 80 degrees here. So pollen is crazy. You should have seen my lecture this morning. My eyes were like visibly puffy. I looked awful. It's fine. It's gotten better, I think. I think I'm looking better. I mean, nowhere to go but up this morning, but, you know. No more lockdown. Absolutely right. I'm still freaking cat-haired. Okay. No more lockdown. Read my lips. No more lockdown. Right, W? I got to work on that impersonation. Close. I hate accidentally clicking on the wrong. Can you not hear me? Because I answered your question. Michelle? I'm not trying to be rude. Just want to know if you can hear me. Because I just talked about it. Well, yeah, okay. Well, all right. Yes, Mo can hear me. Okay. Yes, so. Yes, we're going to do chapter 6. We're about to do it. Doing it right now. Whenever. Thank you. Whenever this works. Just got to smack the... Oh, okay. All good. It happens. When is the actual exam 2? You tell me. Now, your options are... I did not actually put this part explicitly on the slide. So this quiz that I'm talking about right here, let me change my pointer. So this quiz, this one right here, will be available during the day on Friday. And then starting Saturday at 8 a.m. through like Monday night at midnight. Obviously, you won't have access to the exam during the exam. So I should probably put that bit on the slide. That'd be good to have. But it'll be clear once I give you the thing on Friday. But for now, it's good to know. Okay. All right, moving on. If you still have questions about it, I've probably said it before. You can watch it in the VOD later. That's what they're for. And I have started breaking the lectures up a little bit, especially like this one. Good. I started breaking up the lectures a little bit so that I can just like link directly to something like big picture things. One more thing I want to show you guys. So this is kind of off topic. What is going on? Something's whack with my headset. Let's try again. Is it working? Okay, I hear it now. Do you hear my desktop audio? There we go. Dinging. It's working. Good. Okay, finally. Okay, sorry. All right, so one thing that you can do is you can be like, hey, I want to see something that Rob just said. I think I missed it. You can click on this clip button right here. All right, I'm zooming in. Oh, not it. It is that one. Right here at the bottom. All right, so bottom right of the stream. Come down here, hover over. There's clip, or there's settings, and then next to that is clip. So you slap this little button right here, and you will load. Okay, please go away. It will load into this interface right here. So what you can do is you can expand the clip up to a minute back from where you came in. Now, I think you may have to have been watching at the time. I'm not entirely sure how that works. But then you can pick like, I want to get the last 16 seconds or something, and you can watch the clip to see exactly the part that you've gotten. And then you can save it. So you add a title, and you'd be like, really funny joke, haha, whatever it is that you're saving, or quiz tonight or something. I don't know, whatever your title is, and then you can publish it, and then that'll be it. You can come back and look at it later, so you can save it forever if you want to. So that's something kind of handy. I've been meaning to mention how that works. I've actually had 2 students clip my lectures already. So other people are out there doing it. Figured that I might as well say it for everyone. Those are people who already had Twitch accounts when they followed me, so you can tell they've done this before. So that's good. That's exactly what I want. Like, I want people that are comfortable with the software to be using all of its features, and I want people who aren't comfortable to move that direction. So that's great. And I completely forgot how the clipping system worked. I've done it before. I just didn't remember how it worked, and that button was hiding from me. So I thought the button was outside of the player controls. So it took me like half an hour to find it. It was so frustrating. All I could find was like advanced features, and it was like push the clip button. And I was like, where's the clip button? Where's the chapstick? Anyway. Okay, I'm going to come back to this. Yes, absolutely. I try to upload them right after class. That's what I usually do. It does take a while to process. Like, it takes 20, 30, 45 minutes, depending, to actually get the video uploaded. Like, just the time it takes to send the whole file from when I say go to when it actually finishes is like at least half an hour most of the time. And then it has to render, like process. So it takes a while. It takes like at least an hour from when I tell it to go. So, but yeah, I'll have it up. So, it'll be 10 o'clock, but it'll be there. It will be there. What are we doing? Chapter 6? Yes. I was like, chapter 10, where is it? Nope, that's where I am in my analytics class. Perfect, you're welcome. Okay. So, we have 45 minutes. Okay, nice. I didn't talk as much this time. That's nice. 45 minutes to talk about continuous probability distributions. And I've got her in my mouth. Of course I do. Got it. Okay. So, chapter 5, as I hope you know. Oh, you're right. 35. 35 minutes, because it's until 7:05 to 8:20. Okay. I have good news for you. There are already practice exam questions. And it sounds like you missed the start of the lecture. So I strongly recommend that you go back and watch this video later. So that is definitely in your best interest. Also, I emailed the class shortly before class, like maybe half an hour before class, with some stuff about this. So you can look there too. Okay, so hopefully you know that Chapter 5 was discrete probability distributions, which means the way that we measure and talk about things that are uncertain, but specifically those that have nice buckets for the possible outcomes. Like integers, whole numbers are a really nice kind of discrete probability distribution. Whereas you can't hear me. It may be on your end. My stream quality says it's good. Upload solid. Nora says she can hear me. So you can always start refreshing the page if you want. That's always an option. Otherwise, you just have to wait. And make sure your bandwidth is set to auto. It should do that by default, but if you're trying to watch it on like forcing it onto source streaming, which is 1080p 60 FPS, is pretty hard on the bandwidth. So actually, you know what? It says it's uploading at about 2.7 megabits per second, which is really not that bad. So assuming it's coming to you at the same bit rate, then it's you only need 3 megabytes download speed to keep up. So not bad. Okay, so anyway, so now we're going to be talking about distributions where things don't fit into nice, neat buckets. Sorry, I left my speaker on earlier. I have an illustration that I can't reach. Okay. A coffee cup. So, how much liquid is in a coffee cup? Well, I drank this morning, so currently none. But if I had liquid in it, which I've got a water bottle here, I could pour water into it. How much would I have? 3. 3 what? 3 ounces? Okay, well, maybe. But 1 cup, yes. If I'm to use a non-standard measurement, 1 cup might be appropriate. This is a 12-ounce coffee mug, if I'm not mistaken. It's not labeled. I know it holds 12 ounces, so it might be like a total of 14 ounces, something like that. But is it? Let's just take that maximum capacity. Let's just say 14 ounces is just maximum capacity. Do you think it's exactly 14 ounces? Like 14.000000 forever zeros? No way. It's probably close, but like how close? At some point, you can say it doesn't matter, but the idea of it being exactly 14 ounces is impossible. If I had a good enough tool, I could detect the amount of difference that this is not actually 14 ounces. It's a little bit bigger or a little bit smaller, or possibly a lot bit bigger or smaller. We don't know. This is a cheap cup. It's like $2. So it could be a lot off. But the idea of continuous distributions is that maybe it's 14.01, maybe it's 14.05, 13.97. It'll be close to 14. We just don't know exactly what it is. So we might round it for convenience or for the precision of our measuring instrument, but it is not going to be perfect. It's not going to be an exact number. It could be anything. It's a fluid. It just fills the cup, right? So your volume is a continuous variable, non-discrete variable. So we've seen uniform distributions already. We've already seen this in chapter 5, but now it's a little different because instead of it being like 1, 2, 3, 4, 5, or 6, right, in my dice example, oh, they're over there. I'm not going to go get them. Now we have continuous, but it could be anywhere in the range. And then we have the normal distribution, which is the one that we're going to spend our time talking about, and that is very, very, very useful for us. Okay. So, all that illustration is I'm trying to drive insight into this bullet point. A continuous random variable can assume any value in an interval on the real line or in a collection of intervals. So we're talking about real numbers. You're not going to have imaginary numbers, something crazy like that, unless you have maybe some specialized variable, but that's not common. It's not a normal distribution, not a regular distribution in that context. But you will find some distributions that have collections of intervals. Like, okay, this could be anywhere between 1 and 5 or 6 and 10 kind of thing. Like, maybe it's about, so I'm going to give an example in a minute about the weight of a salad in a particular bowl. And maybe you say like, well, customers tend to fill this bowl between like 5 and 8 ounces. But then there's like a really large plate that people will sometimes get like for meals, like a salad meal, and that might be between like 10 and 20 ounces. So depending on the plate, a person might have chosen like 5 to 7 versus 10 to 20 or whatever. So you can have a collection of intervals as well. And like I said, it's not reasonable to talk about the probability of a random variable assuming a particular value, exactly 14 ounces. You can talk about it, but it's just impossible. If you can measure it precisely enough, it's not going to be that number, ever. So if you had an infinitely precise measuring tool, the answer would be, or the value, you would never, ever, 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 ever find a precisely 14-ounce cup. The better the tool, the less likely it is. Infinitely precise tool, infinitely unlikely. So what we do instead is talk about the probability of the random variable assuming a value within a given interval. And so we'll help illustrate that by looking at a uniform distribution. But geometrically, we can interpret the probability as area under the graph. So we'll graph the probability density function, which is the name of the thing that represents our distribution. So we've got uniform, then normal, and then exponential. Our three distributions in this chapter. Like I said, we're really going to focus on the normal, but there's other two ones there. But in any of these three, you see this like light blue portion over here. So this is the area under the curve between our points of interest, right? So an interval is defined by 2 points, a lower and an upper, between 5 and 6 or 7 and 9 or whatever, 5.3 and 6.2, doesn't matter. Between these 2 points, between two ferns, maybe. Yeah, anywhere in there is your interval, and then the area under the curve in that interval is the probability. Now, remember, how much is under the curve? 100%. By definition, it cannot be a valid probability distribution unless the area under the curve is precisely 1. So, that is always the case. So that means part of it is going to be less than 1. So just to kind of illustrate this a little bit, the uniform distribution is the most obvious. So while you don't need to be able to solve the problems, I do want to kind of show you a graphical example that will hopefully help illustrate the idea of area under the curve. So there's this formulas and stuff that we're going to skip. Okay, so here's my salad plates. So let's say that the amount of salad taken is somewhere between 5 ounces and 15 ounces, right? Talking about salad plates and customers. 5 ounces to 15. Okay, so that means the difference between 15 and 5, right? 15 ounces to 5 ounces is how far? 10 ounces. Which is convenient because that means each ounce is 1/10 of the probability. So between 5 and 6 ounces is 1/10. Between 6 and 7 ounces is 1/10. Between 7 and 8 ounces is 1/10. 8 and 9, 1 ounce, 1/10, and so on. So we can say okay, so here all of the each collection of intervals, each 1 ounce is worth 1/10. So it's 1/10 just all the way across. And I can ask myself questions like, what is the probability that a customer will take between 12 and 15 ounces of salad? There's still cat hair flying around me. Please stop. Okay, what is the probability that a customer will take between 12 and 15 ounces? Well, if you just think about it and you say, I know my range is 10, 5 to 15 is 10, and 12 to 15 is 3, what should it be? Well, it should be 3 out of 10. 0.3. So hopefully that just makes sense. Otherwise, we can look at this graphically, where I say, all right, I've got a rectangle. It's 3 wide. This right here is 3. And this over here, this height is what? 1/10. So how do I find the area of a rectangle? Base times height. So base of 3 times height of 1/10 is, of course, 0.3. So hopefully that helps a little bit connect the graphics to the intuition a little bit. Okay. So, in summary, the area under the graph and the probability are identical by definition. And this is valid for all continuous random variables, all of them. guaranteed. And the probability that x takes on a value between x1 and x2, where we're assuming that x1 is the lower value, x2 is the higher value. We can find this by computing the area under the curve of the graph of f of x between the interval from x1 to x2. So all that definition stuff. Okay, so here's the bread and butter. The normal probability distribution. This is where where the magic happens. This is the most important distribution because it is widely used in statistical inference. I find that statistical inference is a phrase a lot of people don't necessarily understand right away, more the word inference mostly. So people confuse the word implication with inference because my understanding of the difference is that implication is an intended extrapolation, meaning that if I imply something, then I'm kind of attempting to communicate something else without saying it. For example, let's say that you encounter someone who is has a bit of an odor. They're having, they're a bit stinky. Well, you probably aren't going to look at them and be like, "Hey, dude, you stink." I mean, maybe you would. Maybe that's your thing. I don't know. Most people don't do that. More likely, you might say something like, "Hey, did you use your deodorant this morning? Are you out of deodorant?" You might try to say something that's a little bit more tactful than just straight calling them out for smelling bad. So what you're trying to tell the person is, "Hey, you're making me uncomfortable, and it would be really nice if you, took care of your hygiene a little better." But that's maybe rude to say it that way. Maybe it's not. So maybe you would choose to say something else and then imply that you would like them to, not stink. So that's implication. You're saying one thing and you're intending to communicate something else. Inference is taking information. Usually it's just like, oh, I've data or, something from a conversation, body language, and you're interpreting some additional meaning based on what you have gathered. It's not really inference if someone just like straight up tells you. It's not you're not inferring anything from there. It has to be like active. So that is what statistical inference is all about. It is using the normal probability distribution to answer questions about what is likely to have occurred or what is likely to occur in the future, and therefore what the significance is of what you have. Is it meaningful? Is the data that you've acquired, is that meaningful at proving, or is it evidence for or evidence against something that you've claimed or that you're interested in? So this process is incredibly important and is actually the entire focus of the remainder of the course after today. So this can be used heights of people, rainfall, test scores, scientific measurements, anything. Doesn't matter. And of interest, this was published by a French guy in 1733. Statistics has been something of interest for a really long time. Which, to put that in perspective, like, that's around the time of, like, calculus, right? That was the late 1600s. Isn't that when Leibniz and Newton were going at it? Late 1600s? Actually, after calculus. I think that's interesting. Okay, so the distribution has this, scary formula. The good news is you don't have to use it. So, I got good news. Hey, girly, come here. No. Come here. I'm picking you up. You smell like oranges. Did mommy feed you oranges? Okay, so the good news is This formula you don't actually have to do, because in order to solve this, remember, we're doing area under a curve. That means we need calculus. We need integrals in order to solve these kinds of problems exactly. So obviously that is beyond the scope of what's expected for you in this class. Although it turns out that the math is actually not that hard. It's not as hard as it looks anyway. It took me a little bit to get the hang of it, but it really actually isn't that bad. Exponents are really easy to integrate and differentiate. So it's mostly just an application of the chain rule. And this entire piece is just a constant. It's actually just a number. So it doesn't actually change. So that just kind of stays the same. And then you just have to chain rule this. And this, by the way, this is also a big number. X minus mu divided by the 2 sigma squared. That's also a number. So you can just plug in a whole bunch of numbers, and it ends up being a number times e raised to a number. It's actually not that bad. Nala is 6. She turned 6 in February. Right? Yeah. Yep, like the Lion King. That's where I got the name. I stole it from Disney. She's like, put me down. She was licking my hand because she knows I don't like that, and she's not happy about being in my lap. Okay, so here's the problem. D2L can't actually do integrals. So when it comes to making exam questions, there's like these formula systems, and D2L can't solve these. So this is where one of the reasons I started getting into some trouble with making the exams. So that's kind of annoying, but that's what it is. Okay, so some fun facts. And these are actually more than fun facts. These are very important characteristics. So number 1, this distribution is symmetric. It's symmetrical, which means if you cut it in half and then, or like fold it in half, right? So you kind of fold it on the middle and then you lay the left half on top of the right half, it will be exactly the same on both sides, which is really important, as you'll see in a minute. Also, the entire family, so any normal probability distribution, any normal distribution, is defined exclusively by its mean and standard deviation. So if you remember, I gave you formulas for those. Okay, bye, girl. I gave you formulas for those things for other distributions. You won't need them for standard deviations. I'm sorry, for normal distributions, because I'm just going to have to give them to you. You cannot know anything meaningful about the distribution without knowing its mean and standard deviation. So that's a literal given. I will be giving it to you to work with. So that's nice. So the mean tells you where the distribution is centered, meaning it's this shape, right? It's a bell curve, and he's cutting off at the wrists, right? So it's a bell curve. And then where it is on the number line is determined by mean, and then how wide is the distribution is defined by the standard deviation. Okay, so center is the mean, spread is the width is the standard deviation. Okay, also of interest, the highest point on the normal curve is at the mean, which is also the median and the mode, which means that the weighted average, the mean, right, the standard average, is also the most commonly occurring point and the middle point. So all 3 most common measures of central tendency are all the same. They're the mu. They're the mean. So that's really handy. Now, the mean can be any numerical value, right? And the examples that I've given, largely, it's like, volume of liquid in a cup or mass of a salad on a plate. These things are obviously either 0 because they're not there, or positive. But something could be negative. Like, let's say that we're tracking the difference between your monthly grocery expenditures compared to an average of monthly expenditures. If you go over your average, then that's going to be a positive number. If you go below your average, that's going to be a negative number. So you might have negative numbers in your normal distribution, and you could even have a distribution with a mean of a negative number. There's no reason why it can't be negative, your numbers could be all negative. I don't know, something like expenditures. And you could just use them as, have them written down as negative numbers for accounting purposes. Okay. Perfectly reasonable. Everything can be, it can be negative, it can be zero, it can be positive. Anything's possible. Okay, so like I said, standard deviation determines the width. And to make sure that's clear, larger standard deviations result in wider, flatter curves, while smaller standard deviations are skinnier, taller curves. So you can see this here. So like the blue one, cyan, whatever color this is the sigma equals 15. So a relatively small standard deviation compared to, compared to the sigma equals 25. So this is a much shorter and wider distribution. So you can see it's sort of like I think of it as either squashing or more like if you have a piece of like a piece of wire and it's bent in that shape and you grab the corners and pull, it'll kind of like skew down, right? So it's kind of the same idea here. So big standard deviations, big wide pictures. Small standard deviations, really skinny pictures. So remember, probabilities for the random variables are always given by areas under the curve, and the total area under the curve is 1. Since our distribution is symmetrical, then by definition, half is on the right, half is on the left of the mean. So that means 50% on the right, 50% on the left, specifically in that portion, which allows us to do some algebra and kind of work some things out in particular circumstances. So that's quite nice as well. So I showed you the empirical rule in a previous chapter. I don't really care about it very often because these are specific values, whereas we're going to be looking at a table of a whole bunch of values in just a minute. So this is some kind of nice numbers to have in your head if you're going to be referencing standard deviations a lot, but otherwise it's not that big of a deal. I guess what I would have you know from this is that 3 standard deviations plus or minus 3 standard deviations is 99.7% of all data. That's a lot. That's almost everything. 0.28% left over. So only 0.28% of all the items in the distribution will fall within 3 standard deviations of its mean, plus or minus. That looks like this. So 1 standard deviation, 2 standard deviations, and 3 standard deviations on either end, so plus and minus. Okay, but that's not that useful. Okay, so here's the real money maker. So I told you that you're not going to have to do the calculus. So how can that be? Well, so for a binomial distribution, there's a whole bunch of tables, right? There's a big table of tables, basically. Well, for normal distributions, we actually have a much better option. For a normal distribution, we can standardize to a standard normal probability distribution. So it's kind of like, so have you ever heard of the unit of a hand? Like this horse is 19 hands tall or something. Well, whose hands? Who are we talking about? So the idea of hands doesn't mean a whole lot. Like, yeah, it kind of got standardized over time. But what's much more useful is something like a meter, a foot, a gallon, a liter, something. I prefer to use metric, but we're in the States, so here we are. We're stuck with the imperial system, which is just stupid, but that's what it is. But the point is that we know it means something. Just because all the relations of the units are stupid doesn't mean the units don't work. They're useful because they're standardized. They give us a common ground. So if I say a foot, you know how tall that is. If I say a meter, maybe if I say a foot or a meter, one of you would know. You would know probably what at least one of them is. Or I guess that's a bad example because they're not equal. 2.55 centimeters versus 1 inch, and so on. So having things standardized makes our lives a lot easier. So what is a standard normal distribution? Well, it means it has a mean of 0 and a standard deviation of 1. Mean of 0, standard deviation of 1. And we use the letter Z to designate this distribution. Why, I don't actually know, but we just kind of do. I've never bothered to ask why, other than rhetorically just now. Yeah, I'm going to keep it that way. Ignorance is perfectly content in this case. We just use Z. That's just the convention. So you see, we have the distribution. Distribution is centered on 0, and the standard deviation is 1. So I haven't really shown you why this is useful or how to get there yet, but just so you know, this is what we're going towards. We want to get to here. Okay. Look at this formula. It's pretty simple. A subtraction and a division. So what's the other name for subtraction, by the way? Difference. You're taking the difference. So x minus mu is literally the difference between x and mu. X is some point, right? It's some point of interest. And then mean is the average of the distribution. So that means we're asking how far above mu is our point of interest x. Okay, that's x minus mu. And then we divide x minus mu by sigma, which is a way of saying in terms of sigma, which remember that sigma is the standard deviation. So we're saying in terms of standard deviations, how many standard deviations above the mean is x? So that's what Z means. Z is how many standard deviations above the mean is x. And this is going to be useful. You're going to need to know that, and interpreting that statement is also very important. So if I say like interpret a standard normal value, interpret a z-score, what that means is, oh, we are this many standard deviations above the mean. All right, this is very, very, very important concept, and it's not complicated. And because it's not complicated, people like kind of overthink it. You know, they're like, oh man, what's this mean? Like, what am I supposed to say? When you see a z-score, that's what we call these, a z-score. And I ask you to interpret it, which I'm not actually going to do on this homework, but like you're going to see it. We're just doing z-scores in standard normal for the rest of the semester. So you're going to see it. Interpret the z-score. Your answer is, it's the number of standard deviations above the mean. Now, if it's the negative number, you can say, oh, like -2, for example. You could say, okay, that's 2 standard deviations below the mean. So you can either say it's -2 standard deviations above, or you can say it's 2 standard deviations below. Either way. Okay? The number of standard deviations above the mean. This is a very important concept that a lot of students miss. Okay, example problem. Last few minutes. So let's say we have a totally random name for an auto parts store that has absolutely no connection to Pep Boys or AutoZone. Called Pep Zone, that sells auto parts and supplies, including a multi-grade motor oil. So the way that they do their stock is that when the stock amount drops to 20 gallons, a replenishment order is placed. So, you know, they order more, basically, which it takes time to get to them. It's not instantaneous. Even if you have Amazon one-day delivery, it's still one day. There is some time in between the stock placement to when it gets there. Let's say that they're not using it one-day shipping and they have to wait, 2-3 weeks. Depending on what you're talking about, like industry-level things, shipments can take weeks or months. So like 60-day shipping, 90-day shipping is not actually uncommon in a lot of industries, which is pretty wild to me. Some things will be like on a boat for 6 weeks. Like it just takes forever, and just freight is just so slow. Anyway, that isn't the case for our AutoZone supplier, but just so you know. Okay, so let's say that we're worried about sales that are being lost, meaning like we have people coming in, look for the oil, and they can't find it because we're out of stock while we're waiting on the replenishment order. I get that a lot. Well, and people tell me that I will appreciate it at some point. I'm hoping that I can make the salt and pepper thing look good. I'm getting quite a bit of gray coming in already, so it just looks like shiny most of the time, but that's a good guess. She's wrong. It's not right, unfortunately. It's close, though. Okay. It has been determined that demand during replenishment lead time is normally distributed with a mean of 15 gallons and a standard deviation of 6 gallons. Okay, so that means mean of 15. Let's take some notes as we go. Which, by the way, this is something that you might want to do. Aha! Mean mu equals, oops, oh shoot. Good job. Okay. No. I hit a button on my mouse and the whole thing exploded. Okay. Mean of 15. This is a mu. It doesn't really look like it. That's what this is. Mu of 15. Standard deviation of 6. Okay. Sigma equals 6. And let's see. Manager likes to know the probability of stock out, which means what is the probability that the demand during lead time will exceed 20 gallons? Okay. So 20 gallons. X equals 20. Oh, geez, that's a horrible 2. Okay. All right, Nor, see you later. We've only got a few minutes left. No problem. You can catch the last few minutes in a little bit when I get it uploaded. Okay. Probability X equals 20. That's the question. Step 1. Convert X to the standard normal distribution. So I wrote down those numbers, and now we just plug them in. X equals 20, mu equals 15, sigma equals 6. 20 minus 15 is 5. 5 divided by 6, well, 6 for non-Chinese people, is 0.83. 5 over 6, 0.83. Okay, Z equals 0.83. Now what? Now we go look at the standard normal table. And so the standard normal table is this guy. So this is the cumulative probability table for standard normal distributions. And so given a z-score, this will tell you the cumulative probability of being that value or lower. So in this case, we said 20 units. We converted it to 0.83. And then using the arrows that are on screen, I'll show you how it works in a second. We find that there's a number, the circled number, 0.7967. There's a probability of 0.7967, about 80%. Chance of the demand being 20 units or less. So 20 units or less means no stock outs. Like, yeah, we're out of stock, but nobody noticed, so don't worry about it. 80% chance of no stock outs. All right? So how do we find this number? Well, you see it says Z in the top left corner, right? Top left corner, which would, I guess, be this corner, kind of. On the left-hand side, so on this side, you see, so the row labels, you see 0.5, 0.6, 0.7, increasing by 0.1. So if we keep going, the next row is 1.0, and then 1.1, 1.2, 1.3, and so on as you go down the table, Along the column label, so I guess this way, you have 0.00, 0.01, 0.02. This is basically additive, which means that this number right here is 0.50. 0.5 plus 0, 0.50. This is 0.5 plus 0.01, 0.51. So this number is the probability of being at z equals 0.51 or less. In our case, we have 0.83, so we find 0.8, and then we add to that 0.03. So 0.8, which is here, 0.81, 0.82, this is 0.83. So it's a little weird. I think a lot of students sometimes have a little bit of trouble getting up to speed with it. But think of it as additive. I think that works, and you'll kind of get the hang of it quickly. And that's really it, except that we were told stock out probability. This is the probability of not a stock out. So if I want so stocking out is not stocking out, which means 1 minus not stocking out, which is 0.7967. 1 minus 0.7967 is 0.2. So if you get something, it's always going to be that or less, and sometimes what you actually want is that or more. So it can help you to draw a picture of the normal distribution and be like, okay, so I'm looking for a thing, and my mean is at 15. That's this bit here. And then I want to know the probability of 20 or more. I'm interested in this portion. So I'm going to look up 20 on the table, but 20 on the table is going to give me this part. But I want this part. So I need to take this number and subtract it from 1. That is the process of solving these questions. And there are some slight variations, like maybe you need to look up 2 numbers and subtract 1 from the other, or something along these lines. But other than that, it's just algebra. You just look up the numbers on the table and just move them around. So there are a couple questions on the practice exam or on the homework that use this kind of a concept, but that's the core of it, is just look up the values or convert from your distribution to a z-score, and then take your z-score, look it up on the table, and then work back and forth. It's not that complicated, but it is unfamiliar. So a lot of students really start to stumble with this, and then all of a sudden it clicks. So it might be a little rocky at first, and then all of a sudden, hopefully, it'll snap. Yes, Daisy. What's up? What's going on? Yes. Problems on the exam are similar to homework problems. That's the point of the homework. Finger guns. I think the problems on the exam will be easier than some of the homework problems, perhaps. I recognize that we're rushing this at the end. Can I do another example? Well, no. Unfortunately not. We have -3 minutes until class is over. So unfortunately, I cannot. We do not have time to do another example. However, there are more examples in the slides. So here's that picture I just drew, by the way. Haha, sneaky one. This is the picture I drew. Here's how you find the solution. If the manager of PepZone wants the probability, here's another example. Here's something else you can do. Here's some more table stuff. Here's some other good stuff. There's more examples on here. What if you can't download the application? You mean lockdown browser? I've got good news for you. All you need to do is go back and watch the beginning of this lecture, and you'll know the answer. Because it's a long answer. I talked for like 20 minutes. You can speed up if you need to, but like the short version is you don't need it anymore. But there's a much longer explanation that you're really going to want to watch. So yeah, go back and watch the video. I actually sent an email right before class. Do these examples have a solution? No. Okay, so that's it. That's all we're covering is the normal distribution. That's it. There's more things on the slides. Don't worry about it. We're not covering it. Is this video in the announcements? No, but there's this video that I'm recording right now that I'm about to finish recording and then upload. I will put on D2L where I put the other videos, which is links to online learning resources, online lecture VODs. It'll be right here as soon as I get it uploaded. You'll see the link in just a few minutes. I can go ahead and make the link, but then when you click on it, it'll say like videos not available. It might be actually. I forgot to turn that off. Oh, that's not where you do it. Just kidding. It was a prank. This one. There you go. Now it doesn't. I'm going to do my first section while I'm thinking about it. Because I have to do it twice. Come on, click the thing. All right, I did it. The practice exam is not graded. Yep, that's why it's practice. Absolutely. It will tell you the right answers. So, like, it should. Let me know if it doesn't. I did test it, but who knows? Maybe I made a mistake. It happens all the time. So if the answers don't show up automatically, let me know. They should, but if they don't, let me know. They did in my testing, but in my testing, it didn't ask me to go to lockdown browser, so who knows? I think I fixed it, but okay. I think that's everything. I'm gonna be trying to catch up. I know I got mostly caught up on email. I didn't quite get back to like Sunday, I think, but I got caught up otherwise. So if you have other questions about stuff, let me know. I think Discord is easier for me to see and to respond to. Email's an okay option, but it's not my first choice. I will get to Discord faster usually. Just because I get, just like you guys do, I get a million emails right now, so everything gets swamped. So I'm catching up on stuff now that I've gotten all these things finalized. So that's it for today. We're over time. If you have any other questions, you can ask them here or in Discord or whatever. Of course, I don't hang out in the stream for very long after lectures, but you can put a message in the Discord or something, and I'll see it. Yeah, mostly. Again, go back to watch the video. Like I said, there's a lot. You just have to watch it. So there's a lot. There's a lot to go over. So I'll cut the video here, and then I will get it uploading so that we can get that started. But I'll hang around for a few minutes.